All right, on the Physics 11 Kinematics Worksheet 2, I'm just going to go over a couple of the responses here. And let's maybe start with question number 2. And that reads, an object moves from 30 meters per second to 120 meters per second, accelerating at a constant rate of 6 meters per second squared. So first thing we do on any of these is we list what we know. So I'll say my initial velocity, VI, is equal to the 30.0 meters per second. So the 30.0 is important with respect to significant digits. So then the final velocity, VF, is equal to 120 meters per second. And the acceleration, A, is equal to 6.0 meters per second squared. Okay, acceleration is always in time squared. So how far did the object travel in this time? So how far is a distance question. So distance we don't know. There's a couple formulas that we'll use. We've got possibilities of using A is equal to delta V over delta T, and this is basically a slope formula where we have VF minus VI over our change in T, which we could write as T2 minus T1. You can see here that there's no distance in this whatsoever. And we have, so as far as what we know and what we don't know in this question, we know the final velocity, we know the initial velocity, we know the acceleration, and we don't know the time. Okay, so we could calculate the time and then plug that into another formula. However, we could just simply look at another option here for a formula. We've got this one, VF squared equals VI squared plus 2AD. Okay, in this one we have the final velocity, we have the initial velocity, and we have the acceleration. We could then calculate for distance. So this formula will, in one formula, give us what we need to find out. Rather than finding the time, risking making a mistake, and then applying that mistake to yet another formula, and then trying to calculate D. So maybe we'll just use this one. So let's rearrange this for D equals. Okay, so rearranging VF squared, we'd have bring this over VI squared to the other side. It would be minus VI squared, and I'll do this in a few steps just to show you, equals 2AD. Okay, now to get D by itself, what we'll do is we'll, let me change colors here, we'll divide by 2A on this side. And of course, whatever we do to one side when we have something with an equals, we have to do to the other side, so we're going to divide that side by 2A. All right, next we'll have this 2A cancel out, 2A divided by 2A, leaving us with D is equal to VF squared minus VI squared all over 2A. All right, so our values here are 120 and 30, so we've got 120 meters per second, and we're going to square that, minus 30 meters per second. We're going to square that, and all divided by 2 times 6.0 meters per second squared, because that's the units for acceleration. All right, so all that has to equal our distance. You can see that we're going to have meters squared divided by second squared once we execute this square here, and we're going to have the same from here. Once we divide out, the second squared will divide out, plus 1 of the meters, leaving us with just meters, which is great because that's what we're looking for, distance. Okay, so let's actually get out the calculator here and execute some of this. We've got 120 times 120 will be our 120 squared, minus 900, which is our 30 squared, so minus 900 equals that. divided by 12, because we've got the 2 times the 6. Okay, so numerically our distance is 1125. So our distance is equal to 1125. And of course that will be meters. So once we square this, meters per second is going to be squared, all divided by meters per second squared. That's essentially what we have. In the numerator here we're just going to subtract some, but in the end we'll have a meters per second squared, which is going to be meters squared divided by seconds squared, all over meters divided by seconds squared. And this is what I was talking about when I was saying that these seconds will cancel with those seconds, and this meter will cancel with one of these, leaving us with meters. So it will be 1,125 meters as our final distance in response to that question. So there you have it.